Good evening, and it's such a pleasure tonight to introduce our speaker, Kelsey Hanson, who received her BS and her MS from Illinois State Museum and is now a PhD candidate at the U of A in anthropology. She's worked all over North America in things like the Eastern Woodlands, Northern Plains, and she's finally come home to the American Southwest. Bear with me for a moment. You know, for those of us who grew up in the 1950s, we watched black and white TV. And our world that we saw was black or white or various shades of gray. Only the coolest, or what were probably called the hippest parents at that time, had color TV, but slowly color TV became more and more common. And it became clear to us who learned to see TV on black and white that we had missed a great deal. The color added a whole new dimension for understanding and to provide a fuller understanding of the world. Well, archaeology, Southwestern archaeology, is sort of in that phase of the 1950s black and white TV age, in a way. It seems to me that we tend to see the ancient past in the Southwest and northern Mexico largely in terms of muted earth tones. That is, color doesn't really play much role in how we think about and understand the ancient past. Kelsey and other scholars have been trying to add the dimension of color to understanding the past. And just like as color TVs improved our understanding, it gave us a much richer understanding of the past, of the world, so too our understanding of color that Kelsey's working on will be very, very helpful and useful for a fuller understanding of what was going on in the ancient past. So her presentation should be illuminating both literally and figuratively, and I now turn it over to our speaker, Kelsey Hanson. Thank you.
Wow. Thank you so much, Paul, for such a warm welcome, and welcome to everybody who has tuned in too. So happy to have you here. Let me get this screen going and get this colorful presentation started. All right, so I hope we can see this. Today, I'm going to talk about the technologies of capturing color. I'm going to take you through a short tour of what color means, how we perceive it, how we create it, and ultimately why we should care. Today, I'm going to try and convince you that the ability to capture color through paint is in fact a technology. And it's just as much a technology as more routinely studied materials like stone tools or pottery. And it's also a technology that I argue has a lot of opportunity for innovative anthropological research as well. Research that archaeologists are really well suited to tackle, but mostly haven't, as Paul has alluded to. The title that I've chosen, The Technologies of Capturing Color, really has two meanings. So I'll not only talk about paint as a technology, how we make it, etc., but also the technologies that I, as an archaeologist, use to kind of reverse engineer this process. So I'll go through some of the technical qualities of paint, of course, how archaeologists can figure them out, but I'll also give you a little sneak peek on how I'm applying this information to answer social questions in the Southwest. So let's begin. The world around us is absolutely brimming with color, and the American Southwest is truly no exception. From dramatic geologic formations to geologic moments like this, to brilliant sunsets like we see in Tucson, etc., green and blue waterways, to little symphonies of wildflowers throughout the year. We're surrounded by color. But before we get too far ahead of ourselves, let's talk a moment. What do I mean when I say color? What is color? Simply put, color is a quality based on light's interactions with the world. Whenever light falls on an object, some of its rays are reflected and some of them are absorbed. The portions that are reflected determine the colors that we see, right? So this was first observed by Isaac Newton in his famous experiment, passing white light through a prism and refracting it into a rainbow. Now, Newton originally published his results using a color wheel, like this one shown here, in which the colors were arranged based on how they appeared in the rainbow that he saw. At the time, artists were fascinated by Newton's discovery. It was a time when art and science were continually learning from each other. And one interesting thing about publications about Newton's discovery at this time is that the spectral colors that he was able to control in real life couldn't be represented very well using the paints and pigments available at the time. So we see this color wheel published in black and white. But artists, again, were obsessed with what he had come up with and began producing their own versions. On the right is one of the first painter's circles by Claude Boutet. And what's interesting here is that Boutet was unable to represent Newton's spectral red, what he's able to produce. And he also really struggled to make a strong blue. So you can see it's actually very patchy in this representation. He was also unable to really make indigo, and he chose instead to make an extra red. And it actually ended up being a very confusing chart because he actually swapped the labels for violet and orange here as well. But anyway, it's a really good example that it's really difficult to capture and translate color, especially through paint. And that's what we're going to talk about today. How people translate color, a product of light, into paint using the materials that are available to them. But one thing that we need to understand right away is that color is not universal. And what I really mean is color categories. If color is a spectrum, like what we see in this image, then where does one color begin and the next one, or end and the next one begin? When Newton passed that white light through the prism to produce a color spectrum, he drew his lines to delineate our familiar Roy G. Biv, right? Red, orange, yellow, green, blue, indigo, and violet. But cross-culturally, those colors are not always the same. The ways in which people carve up the rainbow into color terms varies really significantly. A pretty common example of this is blue and green, right? In the English language, green and blue are two distinct colors, but in many languages, both green and blue are expressed in a single term. The Maya term yash, for example, encompasses both green and blue. And there are many, many other examples of how color systems also include other qualities beyond color that we recognize in the Western world. For example, sometimes colors are differentiated by texture, like whether an object is sparkly or shiny or matte, or whether it's wet or dry. And without talking about these textural qualities for too much longer, there are a number of systems that have been developed that try to dissolve these color categories, right? Systems that try to make the color world that we talk about a little more objective. So one that should be familiar to all the archaeologists in the audience is the Munsell color system. As you know, all good archaeologists dutifully record their soil colors using our Munsell soil color books, like the one shown here. The Munsell color system was created in the 1900s by Albert Munsell, and in this system, colors are defined based on unique relationships between hue, chroma, and value. It was the first system to represent color using a three-dimensional model like you see here. The soil color charts that we archaeologists take from the field collapse that three-dimensional system into pages, so that we use in the field to systematically code our soil colors. In this system, each color gets a code based on its unique hue, value, and chroma. Like all the other systems, it's a color language. It's supposed to be a standard system that we can use to communicate colors in a standardized and easy to read way. Now, each Munsell code gets grouped, I don't know if you can see my arrow here, but gets grouped on the other side into these little categories where we do assign them names, like light red or dark red or something. But something that people usually don't know is that those terms actually aren't standard. So in some ways, we're trying to make it standardized, but there is some flexibility here. So I'm sure many of us have sat in the hot sun debating over whether something is a 5YR 3.3 or a 3.4 or something. And at some point, where does it matter? But overall, it's a system that provides us with codes to communicate with. And another system that I'd like to bring up, just because it's pretty, honestly, is the Pantone color system. It's a pretty analogous system to Munsell, but it's perhaps a little more familiar to the art and design community. So these are images that I pulled from Instagram with the hashtag Pantone Project. And the Pantone Project challenges people to submit photos in which the colors are perfectly matched with the corresponding Pantone color chips, just like we would do in the field with soil colors. The end product is a very fun and visually satisfying project as the dominant tone in the image seems to just melt into the color chip. So, as I've said, while these systems give us a standardized system of codes to describe and communicate colors, they also flatten a lot of textual nuance as well. They collapse a lot of depth and nuance for the sake of direct comparability. So I guess in a sense, these are ways of describing colors, but how do we capture color? Translating our colorful world into new places and new media is not as easy as you might think. How would you convey the colors of this world to someone who isn't there? This may not seem like much of a dilemma for the modern artist, because the vast majority of us will carry smartphones that are capable of taking amazing photos like this one whenever you want. But without this computer in your pocket, try as you might, you really can't copy and paste colors into new media. For those who want to paint a picture of Horseshoe Bend, for example, like you see here, all it takes is a quick trip to the art supply store to get the right colors. Problem solved. You're met with this wall of endless shades of paints, and today's painters are limited probably only by skill and maybe their bank accounts. But as you might expect, this has not always been the case. Without an art supply store, acquiring a palette like the one shown here is really hard. The materials required to make a good paint are not all readily available. They're not equally distributed across the landscape, and some of them are really difficult to process. If you take this palette, for example, using what you could find in your backyard, for example, what would you use to capture these vibrant yellows, greens, reds, and purples? Well, without our modern art supply stores, painters have to work with the materials that they could get on their own. So the natural landscape becomes your art supply store. But as I've said, not all colors are created equal. Some are simply easier to produce than others. Some are simply more abundant. Some are more chemically stable. Reds, for example, like you see here, are pretty easy to produce. Iron-bearing minerals are really abundant geologically, and they're pretty easy to process and safe to do so as well. Other colors are very rare or are very challenging to work with, sometimes dangerous to work with. Some, like greens and blues, are really difficult to acquire, and because they have copper in them, they can be really dangerous to work with. So we'll talk more about this in a moment, but the fact that some colors are so difficult to produce makes it so much more impressive when we look at the material culture in the Southwest. People in the Southwest have this rich and colorful history represented in its material culture. From pictographs to pottery to murals, more portable objects like bows and arrows, people in the Southwest love invoking color, often through paint. And the colorful past in the Southwest is even more impressive, again, when we think about what it required. The ability to capture color from the natural world through paint requires such deep cultural knowledge and skill. Knowledge concerning what types of materials will even work, where and how to get them, how to process them to make sure that they're bright and steadfast, and then how to apply them as well. All of these considerations remain pretty understudied in archaeology. And it's actually really surprising because paint is one of the oldest human technologies. The famous Paleolithic pictographs from Lascaux Cave in France are a fabulous example of the human investment in artistic products. And now we have even older evidence. This ochre drawing here on the left is from Blombos Cave in South Africa, and it was dated as 73,000 years old. So I think part of the problem is that color is often seen as superfluous, as somehow less important than other topics like how people get their food, what their houses look like, that kind of thing. But again, paint is a technology, and because paint is so culturally significant, as I'll talk about in a moment, we're presented with this amazing opportunity to use paint to answer much more interesting questions. So let's break down the how-tos a little bit. First of all, what do I mean when I say paint? We often think of paint as the colorful stuff that comes out of a tube, but again, when you don't have an art store, paint is the combination of three basic ingredients: a pigment, a binder, and a vehicle. Basically, you need something colorful, your pigment, a binder, something sticky to make that pigment stick to other things, and then you need something to make your mixture flow, so a liquid vehicle. These three types of ingredients will produce a liquid paint. If you let this mixture dry, then you're left with what's called a paint cake that can be stored for later use. But before we get there, let's talk a little bit more about what these three different ingredients look like, especially in the Southwest. So first, you have your pigment. A pigment is a granular solid that contributes color. Southwest is full of options: hematite, azurite, malachite, limonite, kaolin, etc. Once you get them, these pigments are ground into a very fine powder using any number of ground stone tools available. Some are soft enough because of their clay content that they don't require much processing, but many do. An important point that I need to bring up right away is that dyes are different. So today I'm talking about mineral colorants, not dyes. Dyes are organic. They're derived from plant sources, so indigo, madder, sumac, cochineal, etc. When dyes are used, the colorant is dissolved and actually impregnates the material that is being dyed. In contrast, the particles in a mineral pigment, they're actually suspended and rest on top of the painted media. So if you look at it microscopically, you'll see pigment particles suspended in a sticky binder on top of the thing that's being painted. A dyed object will not have these granular solids. So pigment, strictly an inorganic mineral colorant. And part of the reason that I don't personally study dyes is that they're really complicated. They degrade quickly, and identifying the actual ingredients used is way more challenging. Mineral pigments are far more stable and lend themselves to non-destructive analyses. Now, as I said earlier, some colors like reds and yellows are geologically abundant. Mostly iron oxides, and variations in color and texture are mostly based on different hydration states in that iron oxide. And then many of them are mixtures too, which also has an effect on the color as well. That'll also result in different trace elements, which can help us discriminate between source locations as well. Those different ingredients can produce different colors as well. So I have red and yellow shown here, but you can also get different gradients between, as well as some purples as well. And I really like this image in the upper right because it's very reminiscent of the Pantone project that we saw earlier. The leaves here, they match the pigment almost perfectly, but they are not the pigment source. You can't get that beautiful pigment by grinding up those yellow leaves. The actual source is below those lumps of yellow ochre. So, and then there are some things that are much harder to produce. Green, for example, is one of the most abundant colors in the natural world, mostly thanks to chlorophyll, right, found in plants. But for one of the most abundant colors, green is one of the most challenging to translate into a paint. In order to capture greens and blues in paint, you'll need to turn to mineral colorants, mostly copper-bearing minerals, right? But your options, again, are quite rare compared to the ochres we just looked at. They're not only rare, but they're difficult to process, dangerous, and yeah, you really don't want to inhale this stuff. It can be incredibly dangerous. And then one interesting thing about processing copper carbonates, especially, is that azurite actually transforms to malachite over time. So it actually changes, and that's why you see azurite and malachite often represented in the same rock, like you see here. But the other issue with working with these minerals is that it can be so difficult to maintain the brilliant color that you see in the original rocks. Conventional wisdom, and what I've already told you, says that a good pigment must be really finely ground. The image on the left actually shows that, from a recent study demonstrating this effect, but in the cases of azurite and malachite, the color actually dulls quite a bit the more finely that they're ground. So in order to maintain that bright blue or green color, you actually have to keep the pigments pretty coarse. And this makes it really difficult in the remaining steps of making a paint that is smooth and lasts a long time, right? Now, these are only a few examples, but there are a number of commonly cited mineral pigments. Reds and yellows are usually attributed to hematite and limonite. And as I said, greens and blues are malachite, azurite. Blacks and whites are admittedly quite variable, but we often attribute them to ferric oxides and manganese-bearing minerals. And white is often attributed to various aluminum silicates, especially kaolin, that kind of thing. But again, this list, and really the scope of my research, goes beyond this list, because this list doesn't include a number of other options. So you see this list circulated in a lot of introductory texts for rock art, that kind of thing, but this list is incomplete. Most archaeological literature is plagued with this problem where the interpretation of composition is usually based just on the color alone without confirming it chemically. So this list is incomplete, so let's expand it a little bit. There are some other options here. So here's a slightly expanded list of other common pigments that we might expect to see, but are mentioned far less frequently. You'll notice that our list of reds expands, includes vermilion and cinnabar. Yellow includes other states of iron oxides as well. Our greens and blues expand to include other types of copper bearing minerals. So while we talk a lot about copper carbonates, there are other things like copper sulfites, like brokenite, as I have listed here, that are also geologically available. One of my favorites is terre verte here, which is our green earth pigment. It's actually an iron potassium phyllosilicate. So it's actually a clay of sorts, but we don't talk about it very often. But I do know of one example where this terre verte has been recorded in a Jornada Kiva mural. So if we keep looking, I think these other options will start to reveal themselves as well. And all these different options, the rest of our list, all have different source locations, all have different processing requirements, and we need to pay attention to what that variability might look like. And you'll notice that the list actually includes a new category here as well. So iridescent agents, like specular hematite, galena, and abalone shell. They do represent a very intentional ingredient that we need to be looking for as well. So simply put, there's a lot more potential variation in pigment sources than is typically considered. And the problem is that we haven't really tried to look for it, at least not in a systematic way, or especially not at a regional scale. When studies exist, they're extremely site-specific. Very little has been done to contextualize this type of variation at a broader scale. But this isn't even the end of the story, because you'll remember that paint has 2 other ingredients, right? So there are 2 other sources for potential variation in a given paint. So once you have your pigment, it's ready to go, you've ground it down or done what you need to do to it, but a pile of powder isn't going to do very much if you want to make it stick, right? So in order to make your pigment stick to an object or a wall or something, you have to add this binding medium, this sticky carrier for the pigment. And there are a ton of options that exist throughout the Southwest. Common examples include vegetable-based substances like mesquite gum, masticated seeds, pinyon exudate, etc., as well as animal-based substances like animal fats or egg yolks. So when we were talking about dyes, I said that pigments aren't dissolved in a binder, they're suspended, right? So when you're looking at them analytically, you should be able to see that your particles are suspended in your binder rather than dissolved in them. And then finally, our third option here, third ingredient, is our vehicle, right? The vehicle is the liquid that is added that makes the paint flow. This is what transforms a solid paint cake into a liquid paint ready to be used. So this is like if you have your watercolor set of paints, and if you were to crack it, kind of like an ice cube tray or something, you'd pop them all out, and you could draw with them like a crayon, or you add water to them to make a liquid paint. Now, often we use water today, right? So our common term watercolor. But other common choices, especially in the Southwest, include things like spit, water, urine, cactus fruit, blood, etc. So many options. And one thing that might be asking is that, well, can your binder and your vehicle, could they be the same thing, the same ingredient, that same moment? Because if you know, cactus fruit can be kind of sticky, etc. And sure, of course. So take cactus fruit juice, for example. It is pretty sticky, so you might not need much more than that. It's sticky enough and it's liquid. But the fact that it could be 3 different ingredients means we need to be looking for them. Okay, so these are our 3 ingredients. So let's put them together. So now you know your basic ingredients. So I'm gonna play this video of a modern artist who is using mineral and earth-based pigments to make paints. So you'll watch them transform this pile of dry pigment into a paint. So in order to get to this point, like we've said, you have to have a finely processed pigment. And you want that to be as fine and as uniform as you can get it. So you grind up into a powder. You might levigate it as well. So this is the process of adding water continually, pouring off what is, after letting it suspend for a while. And at some point, you'll need to add your sticky binder, which is what this artist is doing slowly. However, like I said, there are a couple of different options for this. And while today, a lot of people combine it, so she's using a mixture in her spray bottle of whatever she's using. It's both a liquid and it's sticky. But if you're using a resin-like product, like pinyon exudate or something, then you want to grind it in the same time that you're processing your pigment. But if it's a wet binding medium, then maybe you'll do it like she's doing it now, probably taking place at the same time. So at this point, the artist is keeping the mixture quite thick at the moment. They're mulling it many times to make sure that it's mixed really thoroughly. But ultimately, the goal here, you'll watch it, yeah, it's getting buttery smooth, but it's still quite thick. And what they're going to do is mold it into a crayon to let it dry. And so it's like that paint cake I was telling you about earlier. But if you wanted to use it right away, you just keep adding liquid and it's ready to go immediately. So they're going to keep doing that, but we don't need to watch it anymore. So this basic process, though, will give you all sorts of different paints. Unfortunately, as I've already alluded to, existing information on paint in the archaeological literature is really full of misinformation. You'll see words like paint, pigment, dye, and binder all used interchangeably in the same report. And so this decision-making process, all the complexity that I just showed you gets lost in that process. But what's worse is that often reports will be full of chemical assessments of paint that are based purely on visual characterization alone. So for example, do you know how many ways there are to make red? So while hematite is a common colorant, if you remember from a few slides back, there are a lot of other sources as well. So cinnabar, cochineal, vermilion, mountain mahogany root, cinnabar, as we see here. All of those options, as far as I'm concerned, that's the interesting part, because those colorants aren't equally distributed across the landscape, and they certainly do not have the same processing requirements. They most likely carry very different meanings as well. By glossing over all this important variation, we're missing a lot of opportunities. Long story short, paint production is incredibly complicated, much more so than is typically given credit. Paint is a technology, and I hope I've convinced you of that so far. So to make a paint like the ones that you see in this palette, you're met with this seemingly endless number of technical choices, right? Possible combinations of pigments, binders, iridescent agents, and all these different processing techniques, all of which will result in different paint recipes. When we find these things archaeologically, they're products of an incredibly complicated sequence of decision making. So let's talk a little bit about what this looks like archaeologically. Do we have examples from archaeological sites, for example? And can we use these to reconstruct how paint was made in the past? Yeah, yes, we do. So examples of paint and painted media are actually pretty common in museum collections. And here are just 4 basic categories that you'll find in these collections. You have paint in various stages of production, raw pigment nodules and semi-processed pigment and powders, like up here in the upper left. You also have tools related to paint production. So you have this pebble right here that is actually covered in red pigment that's adhering to it. You also have examples of paint brushes as well, made from yucca, or in this case, is a feather example. And you also have paint cakes, right? Like what we've been talking about. This is an example of what one would look like from an archaeological site. So once that liquid vehicle evaporates, you're left with this processed cake that's ready to go. Now this example has a square hole in it, if you'll notice in the middle, and it's probably related to how it was stored. And there are actually many more examples like this from the same site. And while this example is from the Arizona State Museum, I've also seen very similar paint cakes at the Museum of Northern Arizona as well. And then finally, of course, you have painted media. And I'm especially interested in the technologies of portable painted media like painted wood and painted basketry. But I'll talk more about that a little later. Now, it's important to point out that in my analyses, I'm specifically focusing on non-ceramic painted media. Now, why would I do that? Well, everything that I've told you so far about paint recipes, again, pigment, binder, vehicle, all that kind of goes out the window for pottery. Not all of it, but a lot of it. So the biggest difference is that a binder isn't needed as much because in producing pottery, because the high heat of the firing environment actually acts as a means of binding. So a small amount of binding medium is used to help pottery paint stick to the pot before firing, but it burns away in the firing process, and it's not as quite of a consideration in producing a paint. And then also, because there's been so much great work that's been done in pottery pigment analyses, I'm really limiting my focus to the corner of paint and painted media that has received far less attention. So non-ceramic painted media. And I'm personally most interested in painted wood, the importance of which we'll return to in a moment. Unfortunately, even though these objects are pretty common in museum collections, they're usually filed under pretty erroneous names. So working with museum professionals to track down this complicated sequence of production is really, really important. So thank you to anyone who's watching, who's helped me with this so far. It's been really helpful. But anyway, so now that I've talked your ears up about what a paint is and some of the ways that it can vary, how do we study it? In my own work, I start really simply. I characterize the color of each object in the collection. Like I said before, Mansell's system, it is familiar, it's easy to obtain, and it's pretty replicable. To increase that replicability, I do use daylight calibrated light bulbs like we see here in a dark room, so at least the lighting is consistent, which is one of the biggest sources of error, or at least deviation when you're recording Mansell color. But as you might expect, Mansell only tells you part of the story. Color alone can be pretty deceptive. So let's walk you through an example. So here's a piece of painted wood. And you can see here that there's this blue here. It's a blue layer that's underlying the white. Now, based on the Mansell color alone, the blue paint on the object should contain copper. Most blues that we know of come from copper-bearing minerals. But if you'll notice down here, I have this little assay right here. Chemical analyses actually yielded no copper at all. Instead, it contained a very high amount of iron and manganese with some strontium. So instead of a copper-based pigments, the colorants that were used was a ferric ferrocyanide, known more commonly as Prussian blue and commonly purchased in the form of liquid bluing like that's seen here. So to achieve the pale color shown here, this Prussian blue was then mixed with a white kaolin clay to produce that beautiful light blue. So what this demonstrates is that capturing color in paint, it's a process that's really complicated. And it's something that the color alone won't tell you the full story. So in order to identify the different choices that are being made, we clearly need other types of data beyond the Munsell color chart. So in my research, I turned to 4 complementary non-destructive techniques. I used portable X-ray fluorescence spectroscopy, Raman spectroscopy, Fourier transform infrared spectroscopy, and polarized light microscopy. The 3 types of spectroscopy, this arc right here, these all operate on the premise that different materials react differently when they're subjected to a beam of light or electromagnetic radiation. Put simply, light interacts with stuff in different ways. And when you control the light like you do in XRF or Raman or FTIR, then you can observe how those materials react. And what's important here is that all materials will respond in very predictable ways based on their unique chemistries. So by studying all of these, using these techniques, we can get at the underlying chemical compositions. And I use all 4 because they give different but complementary information. So PXRF, if you're familiar, identifies heavy elements. Raman and FTIR give a little more nuanced information, especially differentiating different types of mineral pigments. Both these techniques are actually able to identify broad categories of organic binders as well. And then finally, PLM, or polarized light microscopy. This is a real staple in pigment research because you can observe diagnostic optical properties. And it can also, unlike the other ones, which are kind of point and shoot, you zap them and you see what happens, this one you can observe different shapes of pigments and you can analyze different processing techniques based on how uniform or homogeneous or heterogeneous the mixtures are. You can also use this to identify various forms of the same kind of chemical signature. So if you take calcium carbonate, for example, lots of things will yield calcium carbonate. Chalk, coral, different types of shell, they'll all come back as calcium carbonate. PLM is actually the only way to differentiate between these different forms of calcium carbonate based, again, on their shape. So anyway, with all these techniques combined, I can get a pretty good idea of what a given paint was made of. And it's worth mentioning at this point that there are plenty of other techniques out there too, especially ones that are better at identifying trace elements or organic materials. But I've really tried to focus my work on non-destructive or minimally destructive techniques because the objects that I'm working with are really, really sensitive. And then doing this also allows for repeatability as well. But okay, so this is great and all, but how do we use all these data that we're producing? Or put another way, how do we operationalize the technology of capturing color? Who cares? Why is it important, etc.? To me, the ways in which paint ingredients are acquired, processed, and applied means that they have storied paths. And in my research, I'm trying to reconstruct those stories. So I'd like to give you at least one example of what this looks like. As part of my preliminary research for my dissertation, I analyzed 14 paint cakes from Turkey Hill Pueblo, located outside of Flagstaff. Now, excavated by Byron Cummings in 1928, this site yielded a number of paint cakes, right? All these examples were variably cataloged as either red paint or red pigment, both terms used interchangeably. All these examples were excavated from 3 different rooms, and now visually, they all look pretty similar, right? They're all red, and I can see why it was, they were probably cataloged this way for brevity and because they weren't analyzed. But my question is, did they all follow the same recipe? Or they all made the same way? So I analyzed them with the same techniques that you just saw. And my analyses shown here, and these admittedly kind of difficult to read graphs, but they indicate that in fact, different recipes are represented. So each row represents a different room. So you have room 20, room 30, room 11. And each column represents a different technique that I used. So let me point out a few things. So let me start with the PXRF. So rooms 20 and rooms 11 both yielded kind of predictable amounts of iron and calcium, but 2 of the samples from room 30 yielded some trace elements that the other ones didn't have, so strontium, copper, etc. And this suggests at least that they are likely from different sources. And then the FTIR and the Raman, they actually indicate a little more nuanced differences as well. It's a little hard to see, but I color-coded them based on similarities. So the yellow lines, for example, within a given room are more similar than the red lines. So in interpreting these based on the different diagnostic peaks that are represented, et cetera, you actually have at least 2, if not 3 different recipes represented in these rooms. So to summarize, in room 30, there are at least 2 different recipes that are being used. In room 11, there are 2, maybe 3. So I'm arguing that overall, this means that they were produced following different learning frameworks in different communities of practice, different source locations, different ways of mixing things, et cetera, that produce different products. And so, admittedly, one thing that I didn't do is look to see how different recipes compare between rooms. So were they sharing, for example? My preliminary results suggest that they probably weren't. They don't look that similar, but I could take a closer look too. But imagine what would happen if we then compared those recipes with examples of painted media. Are the paints stored in room 30, for example, used for something different than those stored in room 11, right? And then what does this tell us about social relationships, about networks of practice, of knowledge and production or sharing? So thus far, I've talked mostly about the technological qualities of paint. And at this point, I think it's worthwhile to stop for a moment and discuss some of the social and cultural significance of paint and the significance of being able to identify communities of paint practice. So across the Southwest and really North America writ large, painting is often described as an act of imparting animacy. By painting something, you invoke animacy. You make it come to life. Nieves Zedeno from the School of Anthropology once described red paint as one of the most sacred substances in all of North America. Now, obviously, I'm talking about more than just red paint here, but it's worth pointing out that the act of producing paint is often driven by ceremonial needs, an act of chromatic prayer, as it's been referred. Ethnographically, we know that in some cases there are really important reasons why using certain types of paint in certain contexts. Pigments from very specific locations may be restricted to certain ceremonial contexts. And in some cases, whether your binder is from a plant or an animal is important. There are all these important details. And there's a great deal of information in ethnographic sources that do give some insight into these different rules. I do hesitate to divulge too much information at this point because my ongoing research does involve consultation with members from descendant communities. So I do want to hold off. But suffice it to say hold off on the content of that type of thing. But suffice it to say that there do appear to be rules. And in some cases, those rules seem to be passed down or taught in highly structured contexts. So yes, in some ways, paint is very messy. There are so many options and so many variables. And today I've been emphasizing difference a lot, different recipes, different sources, etc. And I'm kind of doing this because archaeologists have been historically really bad at recognizing diversity in paint. But an important question here is that if everything is so different, then how can it be meaningful? If every paint is unique, then how can we use that information to say something interesting? Well, yes. So on one hand, paint is very complicated and diverse. But on the other hand, there are some qualities that are highly controlled. So when we see similarities, that means even more. It's very significant, I think. And if these things were taught, as I suspect that they were, then maybe we can use these similarities in technology to reconstruct different traditions of paint practice. So my plan is to take the show on the road a little bit, to investigate the Chaco world. My dissertation research is going to use paint recipe data to investigate one of the most influential archaeological cultures in the world, from the Southwest, but probably the world too, the Chaco world. I don't have much time left, but let me give you at least the basic premise. For those who might not be familiar, located in the heart of the San Juan Basin, archaeologists characterize the Chaco world as this vast regional system, mostly based on shared ritual architecture, like what you see here. Chaco is famous for its impressive architecture, its exotic goods, and frankly, its unprecedented rise to power. Fueled by several waves of migration from different parts of the Southwest, the Chaco world was this huge multicultural hub, and it's full of convergent identities and emergent power structures. Now, Chaco's unprecedented rise to power and its eventual dissolution offers an ideal scenario to ask how differences within this diverse populace were negotiated. How, for example, did Chaco leaders achieve and maintain authority across such a diverse populace? To answer this question, I'm evaluating the ways in which specialized knowledge is circulated both within and between communities. And I'll be using, you guessed it, paint and painted material culture. As such a culturally potent material, the analysis of paint should reveal networks of knowledge. And I suspect that this should represent shared learning and production environments. So how is this knowledge distributed across the Chaco world? I'm using similarities in paint recipes as a proxy for the settings in which that ritual knowledge was passed down. Not as a way of understanding the content of ritual knowledge, but using similarities in recipes as a way of identifying shared production settings. Now, Chaco sites have yielded some of the most remarkable examples of painted media in the Southwest. Here are just a couple of examples. But I'd like to point out that, yes, they're old, obviously, but the colors here are so vibrant. And if you look at this top one, for example, you have so many beautiful colors represented, some of which are very difficult to produce. And the quality of painting, the skill that is represented here, if you look really closely, that you can see this yellow border. It's just a really fine control of the material, of the paint technology. Some of these objects appear to be parts of three-dimensional mobiles or parts of altars or something. Others may have functioned as parts of costuming worn during different performances. So far, across the entire Chaco world, I've identified a sample universe of a total of 5,016 objects worthy of inclusion from a total of 29 sites of Chaco and post-Chaco sites. Now, this includes from both great houses and small sites. So this includes over 4,000 examples of either processed pigment or paint cakes or something like that, 130 tools related to paint production or application, and 426 examples of painted media. Obviously, I'm working on a sampling strategy here, most of which is constrained by how much money I can rake in from grant proposals, all of which will fund my whirlwind museum tour. But basically, I'm gonna do exactly what I did for Turkey Hill Pueblo, but on a much bigger scale. And I anticipate finding some really interesting information to help explain the emergence and the maintenance of social dynamics in the Chaco world. And perhaps some new insights into how that knowledge was disseminated across the Southwest, especially in the post-Chaco eras. Where did this knowledge go after the Chaco world kind of dissolved after it dissipated? Given its relative ubiquity, its deep cultural significance, and the fact that we can differentiate different paint recipes, I personally think that paint has a really important role in unraveling the socio-political dynamics in the Pueblo world. I'm just starting with the Chaco world, but I think there's a lot more to do there as well. And it's important to point out that while my research is centered on paint technology, it's really mostly concerned with the emergence of social inequality, craft specialization, that sort of thing, and new ways of discussing how power is circulated on the basis of knowledge. But admittedly, that's all really a story for another day, because that part's really only just beginning. So stay tuned for the rest. But before I wrap up, I'd like to end by bringing things back to where we started. To me, ultimately, we need to remember that the act of capturing color through paint is fundamentally a technology. My research investigates how people capture and communicate color, and ultimately how that information was passed down, and perhaps in some ways controlled. If we want to understand how concepts of color are expressed or how they've changed, we also have to understand the full range of technical choices that are made along the way. To me, that's step one. And there's a lot more magic to be found through collections-based research, especially as new methodological techniques are made available. I really think that collections-based work is where we're going to see a lot of exciting new turns in archaeological practice. Now, my work is still developing, but I suspect I'll have more things to share soon. So with that, thank you so much for your time, and I'm happy to answer any questions. And before I turn it over, I guess my quick acknowledgement slide as well. Thank you. This is a short list, but it's not exhaustive. But thank you to all to have helped contribute in more ways than one to this ongoing research. But with that, thank you so much. And yeah, happy to answer any questions.
Thank you so much, Kelsey. That was pretty awesome. Lots of good information in an area that I know a lot of us have not really thought about before. So thanks. I have just a couple of questions to start with, and as we wait for a couple more to come in, I do want to make a correction to something I said earlier. The presentation for November 16th is by Jeffrey Altschul, and the topic is using the past as a bridge to the future. He is working on an initiative to use archaeological data to solve current problems. So it's a very timely presentation. So I just wanted to make that correction, and I apologize for that. Okay, I have a couple of questions coming in.
Sure.
And the first is, did you analyze color at all using the CIE LAB system?
No.
Not
No.
at all. Okay.
No, I didn't. It's one that I actually have only just started learning about. So whoever this is coming from, happy to talk more about that or hear some insights on pros and cons. But no, short answer is no. I've really been focusing on, and really there's a whole lot of developments in new colorimeters and things, new ways of describing color that are becoming more available. And my decision to use Munsell, at least at this stage, is again because it's cheap, it's easy to produce, it's easy to schlep a book around with me, that kind of thing. But I'm open.
Yeah.
I'm open to new
Great.
systems.
So that goes along with the second question here. Which of the spectroscopy methods is portable?
Yeah, good question. So is it worth going back? Let's see. There it is. Yeah, so the of these, the portable X-ray fluorescence is by far the most portable of them. So all the other ones, really, there are portable options available, but you lose a lot of accuracy by doing so. So portable Raman spectroscopy instruments are becoming available, but because what you're doing is trying to control how light is interacting with your object, it's really hard to control that in a handheld device. From what I've heard anyway, they exist, but they're really difficult to get good results from. So in fact, I didn't talk about mechanics of sample preparation here, but I do emphasize the use of self-sampled material. So this is material that's already fallen off an object, and if it's already fallen off, then I can take the tiniest micro sample and move that to the benchtop machines. So the only one that's truly portable is the PXRF.
Okay, thank you.
Mm-hmm.
How about, have you put any thought into using paint to understand the cultural differences between small sites and the great houses in the Chaco Basin? And perhaps the difference between the people using those two different sites?
Absolutely, absolutely. And that's actually why I've set the research up to look at those differences. So I'm not only focusing on the great houses, I'm interested in the dynamics between small houses and great houses. There was a thesis done by Candace Lewis that actually looked at a little bit of this in terms of the relationships between pigments and painted media between great houses and small houses. Now she had only looked at greens and blues and the presence and absence. So yes, the short answer is yes. I'm very, very interested in the dynamics in terms of, are these being made in the smaller sites and being brought to great houses? Is it a function of proximity, or is it a matter of the small sites that are closest are the ones producing everything? So yes, short answer is absolutely. I'm very interested in that.
Great. Chaco had trade routes throughout Mesoamerica. Do you know of any Latin American colleagues doing similar color research?
Sadly, no. I need to reach out south of the border a little bit more because there's a lot of really amazing opportunities there to look at how these very prized technologies and raw materials are being circulated. And I think that absolutely there's probably a great chance that conversation really deserves to happen across international borders as well. But thus far I have not. But if you know of anybody, love to know.
Yeah. Okay, and this is about supplies. Where do you get the photo bulbs, daylight bulbs, and to get that real color?
Mm-hmm. Yeah, fortunately, I get to work out of the conservation lab at the Arizona State Museum, and they have a lot of stuff. So it's already in the lab there. So I don't know where they get them necessarily, but I think they're easy enough to acquire.
Okay. And do you think similar color recipes will appear on different media at the same time?
Sure. So that's one really big question, is that, will paint recipes only differ because of the different media, the requirements of different substrates? So certain paints might just work better on wood versus stone or something. And then, yeah, I do think that it would be totally reasonable to expect shifts through time or different emphases of maybe related to changes in pigment sources or processing kind of traditions or something. And I bet that will change through time. I don't have an answer now, but I would expect to see something like that.
Great. Here's a fun one. Do you paint?
You know, I'm really bad at it, actually. Well, I guess I'm good in an abstract way. But no, this research really didn't come out of any long held interest in painting or anything like that. But it's inspired me to take it up in small ways. So
Okay.
not yet, but more later maybe.
That's related to this next question. From Rachel. As someone who knows you have lots of varied and diverse intellectual interests, can you tell us a bit about why you became interested in using color as a mechanism for investigating more complicated questions about inequality and power?
Yeah, absolutely. And thank you so much for that question. You know, really, my choice to come at paint as a technology came from an interest in caves, actually. So a lot of the painted wood, painted media, whether it's painted walls or whatever, that was really what I was starting to find in these settings. But my initial plan was to go and map a lot of them, but that plan didn't work very well. I was left with a lot of museum collections that I was hoping to do some sort of spatial analyses with them. And the only way that I could make sense of any commonalities or similarities was to create new types of data. And so I was interested in how do I problematize these kind of orphan collections. So that's really where the initial shift came from. And then my forays into some of the ethnographic literature made me realize just how socially and politically significant this technology actually was. So it was a series of happy coincidences.
So have you made your own paint in a traditional manner? And if so, what was the biggest challenge? And if not, what's the greatest barrier? Or what do you think would be the hardest? Yeah.
Absolutely. The biggest challenge is finding the right material. So initially I tried to go out on hikes and find stuff. And yes, there's tons of things available, but getting an eye for the right types of what will work takes time. And so I have done deep dives into YouTube and you know, people who do it on their own. The short answer is, yeah, I do have a small setup in my apartment, and I do process pigments that I either find on hikes or I have purchased a number of standards from certain paint companies or pigment companies like Kramer Pigment, based in Germany, but also has a location in New York. So I'm developing a comparative collection based on both standards and stuff that I find too. And the biggest challenge really is, in some cases, that processing it is dangerous, right? So I have a studio apartment and a cat, so I can't do a lot of it in my apartment. So I have to bring things outside. The pigment processing, mulling, and actually making the paint can happen inside. But it's taken a lot of fine tuning of what tools I need to have, you know, what things work best and how do I store everything safely and that kind of thing. So it's an ongoing process, absolutely. But I'm happy to report that I do have a pretty good comparative collection going right now.
Great. Here's one. I have some painted imagery at a petroglyph site in this area. One exposed panel is red near the top, but then fades to pink in the more exposed area below. Would that more likely be a dye?
Well, so sorry, so can you repeat that? So it
yeah, so
fades.
It fades, it's an exposed panel and it's red near the top, but fades to pink where it's more exposed below.
Right.
Is that more likely a dye or is that paint?
You know, I would suspect that it's a paint, but again, so there are lots of ways to make paint. And if it's a mineral pigment, then there are certain ways that could discolor because of shifts in the binder. Binders contribute color as well. So it could be shade that are like organic changes that are happening to the binder itself. Could be any number of things. Another possible option is that any given paint might have their mixture is right, so they might have a bunch of bright red mineral inclusions in them that might be the predominant color, but there might be kaolin that's added or something, so maybe some of the red is starting to fail or fade away in the most exposed areas, leaving more of the white portions. it's hard to evaluate that without seeing it. So it's possible, but I would suggest that it's probably probably a paint still.
Great.
Yeah.
How about this? What do you think of Steve Lexon's Chaco Meridian hypothesis, and can you explore it with your research?
Yeah, so I'm very interested in the shifts in power after Chaco dissolves, right? And so while I in my current research, I'm not necessarily looking to look at what happens with Pigment or anything like that, at least at this stage. I am interested in looking to see where this knowledge moves afterwards. So I will say that I will be looking at other post-Chaco centers. So I don't know that I'll be looking to evaluate Lexons necessarily at this stage, but I will be looking at where this knowledge moves afterwards. And maybe that'll offer some more nuance to that argument as well.
Gary says, thank you, Kelsey. Does your research include attempting to identify the source locations of the pigment materials?
I'm really, really glad that you asked that. And no, not, not at this stage. So at this point, in order to do provenance-based research, you really need to know the full range of variability in the material that you have. And then provenance-based work is really based on fingerprinting, right? It's fingerprint matching. So you take your known universe and you match it to the geological availability. So in order to really do that, and because Chaco has such expansive trade networks, that'd be a huge undertaking right now. I suspect that a lot of the pigments are coming from really far away. So we know that some really important sources for red come from all the way to the Grand Canyon. There's a lot of possible options, and at least at this stage, that would be a point for more collaborative work with somebody who's more has other interests in identifying the geologic availability to start a fingerprint matching protocol.
Okay. Do you think communities of practice of color technicians bridged craft specialties, for example, wood, rock, pottery? Or did each craft prepare paints in different ways and perhaps have different sources?
That's either way it's likely. And I think either would be very reasonable. I could see it going either way. I could see that certain communities of paint practice might be in charge of making certain sets of things, but we just don't know what those categories, where those categories begin and end. So I'm hoping that my work would actually help to identify, how the production of those types of products actually occurs. I honestly would expect any scenario at this point, and any of them would be pretty interesting. Yeah.
Great. And are there ways to analyze the quality of paint? For example, the color, the durability, et cetera, the quality of it?
Mm-hmm. Yeah. So in a sense, there's a sense that some of it is going to be visual, but for me, the polarized light microscopy is where you get a lot of the being able to assess the fine qualities of a paint. So it might look visually very stunning and very controlled, but the PLM is really going to be able to show you why. Is it because the pigments are so uniform and so fine and so, uniform, et cetera? Or, and in some cases you can get maybe brush strokes or something in some cases to look at how finely controlled that is. So I would say that really becomes more of an intuitive visual assessment from the PLM.
Okay. And Robert asks, are you working on any rock art?
That's a lovely question. And again, the short answer is no, I'm not right now. And it's mostly because, again, I'm trying to really understand this technology in mostly controlled settings. Pictographs are by nature really open to the elements, and they introduce a lot more types of variability and more types of degradation as well. So while I'm really hoping that my work does help inform that type of work in the future, that's not really the scope of my work at the moment.
Okay. Jane Colber has a comment here. If you're looking, and it's related, you're not looking at pictographs at this point, but she says the paints at one site in Chaco have been read by PXRF. So just so you know that.
Yep.
And then, are you going to examine any samples from contemporary sites outside the Chaco sphere of influence, such as Kayenta, to discern which paint practices are unique to Chaco and which are more pan-ancestral Puebloan?
Right. That's such a great approach to assessing whether this is unique and controlled and a really special Chacoan kind of thing. At least right now, at least at this stage, I'm not, but I do want to be developing a comparative space to really say something meaningful about how specialized is this.
Mhm.
So,
Mhm.
but that would be a really good way to do that.
Great. And can you give some examples of how paint is made during certain rituals without compromising the confidence of your indigenous informants?
I would prefer not to. Yeah, a lot of that information is pretty easy to find, honestly, in some of our classic ethnographic works. And there are some very interesting settings, contexts, and rules that seem to be governing this practice. But at least right now, because a big portion of my research as well is conducting interviews and these things with descendant community members. And I want to make sure that before I divulge things, even if they're published, that I'm being respectful of how and the content that I'm sharing. So I'm going to respectfully decline. Yeah.
Thanks. Okay, I have just two comments about, one is, let's see, the Hunter Lab spectrophotometer, I don't know how to say it, spectrophotometer is portable and can analyze color by blocking out external light. It uses the CIE LAB system of color analysis just for,
Oh, sure.
Yeah.
That's good to know.
Yeah, and then someone says you can get daylight bulbs with high color rendering index at any photography supply store. So that's, and then the final question, have you found any instances of contemporary artists using identical or nearly identical pigment binder liquid combinations to what you've come across in archaeological sites?
I have not yet, and that's because I'm really only beginning developing those personal connections with contemporary painters. So in some ways, from my preliminary conversations, yes, there's definitely continuity, especially when certain pigments are very, very special. But I don't know how consistent that is in other spaces or contexts yet.
Great.
It does seem like there are some that are really, really important and long-lived. Mm-hmm.
Get passed along from, yeah. Well, thank you so much, Kelsey. That's all the questions we have tonight. And thank you very much for taking the time to share with us. And we're looking forward to your data later. When you've done some more, and you've got quite a few comments about thank you, and it was a great talk. So.
Oh, wonderful.
Yeah.
Well, thank you so much for having me. And as much as I would love to see everybody, I'm glad that so many people were able to tune in. And yeah, looking forward to sharing more when I have
Great.
more.
Great. Thank you so much. Have a good
Thank
night,
you.
everyone.